Okay, and what we have to do now is apply this free body diagram thing to our experiment, figure out what the algebra is, take some data and analyze it. So first off, this is the free body diagram of the experiment we're about to do. Here are the equations that have come out. These two are the x and y directions of F equals ma. These two are from physics that we know. And we have to put all this together and wind up with a solution. What we're looking for is some way to find mu s out of all this mess. So what you do in a case like this is the best way to do it is to figure out what kind of algebra you're going to do before you start doing the algebra. And what I want to do is combine all this stuff together. And looking at this, I have W equals mg. I can substitute that in here and here, and then we won't have to worry about W anymore. I have SF equals mu Sn. I can put that in up there, and then we won't have to worry about Fs anymore. It doesn't show up anywhere else. So if I do that, I get this. I take the x equation, substitute for Fs, I get mu Sn minus big F plus substitute mg for W, mg sine theta equals 0. And then in the y equation, I have n minus substitute mg for W, mg cos theta equals 0. Now I've gotten rid of W and Fs. I'm down to two things I don't know, n and mu s. This one I can solve for n and then plug into there, and that will get rid of n. And I'll just have one equation with mu s in it. So let's do that. This thing leads to n equals mg cos theta. Plug that in up here, I get mu s times mg cos theta minus f plus mg sine theta equals 0. And I'm almost there. I want mu s. I can move these things to the other side and divide by that one. And I will wind up with mu s equals f minus mg sine theta over mg cos theta. And that gives me a formula for mu s. So I can use that in my analysis. All I have to know is the mass of the stuff on the cart, what the angle is, and what the force is it takes to make it move, and I will get the coefficient of static friction. Good, so we got through that. Okay, now it's time to do the lab and take some data. To do this lab, what we've done is taken the piece of glass from a few weeks ago and we've tilted it. I have this currently set up for a 30-degree angle. That's probably the maximum you want to use. Something less than that may be a good idea. To verify it, I have a ruler and I've measured the height it's propped up at versus the length of the side here, and this is a 30-degree angle. We also, as far as equipment goes, we're using the Newtonometer from last week, and we have the same sled with the thread tied to it. We have some weights. The weights this week are packaged up in tape so they won't fall off the sled. We're going to have to weigh the tape when we attach those. What we're going to be doing this time is essentially the same thing we did last time. We will be measuring the static and kinetic coefficients of friction by dragging the sled up the hill and using this formula corrected for angles to figure out what we have going on. So let's just jump right in here. We'll start off measuring the mass of the sled and just do a run with the sled by itself. The mass of the sled turns out to be 92 grams, just the same as it was last time. That's good. To measure the coefficient of static friction, we put it on this sloped hill and see how much we have to pull on it to drag it up the hill. This is more than it was last time because now we're pulling it up the hill as well as overcoming static friction, but hopefully it won't overload the meter. It starts sliding when I get up to about 0.76 newtons. Let's just punch all this into the spreadsheet and see what we get. I have a new spreadsheet opened up. I'm going to make one column called surface, another column called mass, and I'm going to have a third column called angle. And the angle I'm going to put in will be in degrees, and it turns out that the sine function in this spreadsheet wants it in radians, which it's always one or the other, and somehow I usually pick the wrong one. So what I put in here to fix this is I've just taken my angle in degrees and multiplied it by pi over 180, which converts that to radians, and we'll make a column for that. And now put in a force column. So when I'm going to be calculating with this, it will be mu static, and we'll make a column for that. And start off with the surface is glass, the mass is 0.092 kilograms. The angle I have here is 30 degrees, and the force 0.76. Mu static comes out of this equation. I have to type this into my spreadsheet. So I get equals, and the force minus mass times 9.8 times the sine of the angle and I want that divided by the mass times 9.8 times the cosine of the angle. What I get out of this first measurement with just the sled is I get mu static of 0.396, which is reasonably close to what we got the last time we tried this. Okay, our next experiment is going to be to increase the weight on the sled. And to do that, we're going to use one washer with some tape. The tape will just keep it from sliding off the bottom of the sled, but it does mean we have to remeasure the mass of this thing because the tape has a little mass on it too. And that's coming up as a mass around 18 grams. We subtract the two that are sort of always there, it's 16 grams. Now we tape it on the sled and hook up the thread to the Newtonometer. Bring it over here, and we can do this experiment. So we're starting to pull up the hill with a weighted sled, and it starts moving right about 0.90 newtons. Let's go back to this and put in the numbers, see what comes out of it. Back to our spreadsheet. We've got glass as the surface again. The weight now is 92 plus 16 is 108 grams, 0.108. The angle is the same, 30 degrees. And the force we came up with was 0.90 newtons. So we got that. And finally, we get for a mu static 0.404, which is darn close to 0.39. It's actually extremely close. So we've done this experiment twice with two different weights. We've gotten results that are in fabulous agreement. And what I want you to do next is to try getting the kinetic coefficient of friction and then try changing the angle. Take the angle down to 15 degrees or something and see what you get for that. And then send me the results.